That transistor is vaping smoke. Why is the question? That thing is going crazy. How about 2 things of americium? In my previous video, I talked about using a Geiger counter and hooking it up to a CD4026 LCD display counter. And that was pretty cool because we were able to catch those really short pulses with the Geiger counter to actually count how many pulses happen within a certain amount of time. We were able to calculate the amount of radiation in millirem per hour and year. And we were able to see that my room has actually twice the national average of background radiation, which was very interesting. But in that video, we tried to make this Geiger counter work with an old-fashioned electromechanical counter, and I wasn't able to do that successfully. It didn't work. So in this video, we're going to make it work. So this is the little Geiger counter circuit. It's basically an amplifier with a bunch of transistors on it. And we also have a power supply or capacitor bank. We charge up pretty high to about 450 volts. That runs the B plus for the Geiger tube. I've also got some little batteries that run the little amplifier circuit, 4.5 volts, with a speaker. And then we have our empty perf board with a pulse out pin, and this is what we're going to be building our circuit on that is able to make it play on the electromechanical counter. Now, the issue with using this electromechanical counter with a Geiger circuit is the fact that the pulses from the circuit are extremely small, and the pulse doesn't give it enough time to fully run through its little cycle of moving a digit to the next digit. So basically we need to build a circuit that will extend the very small pulse that's on the order of milliseconds from this device and make it so it's probably maybe a quarter of a second for the electromechanical counter to work properly. Now we're going to do that by using a 555 timer in something called astable operating mode. Alright, now let me explain a little bit about how this circuit is going to work. So this is my circuit for the Geiger counter. As you can see, it's got all the transistors and all the amplifiers, and it has this pulse out pin that sends a very short output pulse. And basically what we're going to do is we're going to connect these 2 schematics. So we have the output pulse from the Geiger schematic, and this could be going to my next schematic, which is a monostable 555 timer circuit. Alright, so this is a monostable 555 timer circuit. Let me explain a little bit about how it operates. So basically what happens is you have this transistor that goes from the pulse in pin, and the input to pin 2 is typically high through this pull-up resistor. But when there's a small pulse on the input transistor, it brings this pin 2 to ground, so it brings it low. Now, pin 2 is the trigger pin of a 555 timer. And then our other 2 important pins are 7 and 6, and that is threshold and discharge respectively. Now what happens is when the output to the 555 timer is low, then the discharge pin is going to be to ground, which means that this whole circuit will be to ground through this capacitor, and this capacitor will be fully discharged, and the current will go through this resistor to ground through there. Now what happens is when you put the trigger pin to low, it's going to make the output go high. When the output's high, that means the discharge pin will stop, and pin 7, which is the threshold pin, will be reading the voltage on this RC circuit. What's going to happen is the capacitor is going to charge through this resistor because now it's no longer being discharged by the internal schematics of the 555 timer circuit. What's going to happen is the current's going to flow through here until the capacitor reaches 2/3 of its supply voltage. Once that happens, the threshold pin will read that, and it will shut the output off. And once the output is shut off, then the discharge pin is going to turn on, it's going to discharge the capacitor. So, the values of this resistor and capacitor are going to determine the amount of time this 555 timer stays on for after it is activated. As you can see right here, I've got a resistor going to a transistor. This transistor is going to turn on the little electromechanical display, and it's going to use this reverse protection diode to prevent any current from messing up the circuit. Because basically what happens is if you supply current to an electromagnetic circuit, like a relay coil, it'll build up an electromagnetic field, And then once you remove the current, that field has to go somewhere, and so it'll have a much higher voltage once it collapses. And typically that voltage would flow throughout your circuit and mess things up, and it would trigger my Geiger counter as I previously showed. But in this case, it'll just go through the diode and discharge itself. Let's build this. Alright, okay, hold up. You missed it. I just fried something. In my circuit, a bunch of smoke came out. Not sure what it was or why that happened. I know whatever it wasn't good. Let me try that again. That transistor is vaping smoke. Why is the question. Okay, gotta turn on my powers. Just a second. I gotta turn on my fan because there's so much smoke. No bueno. Oh, now it smells in here. This is annoying. Alright, now that we've got some ventilation going on here, I'm gonna take a moment to explain what happened. So this transistor went up in smoke. It's because I put it in backwards. Don't do that. You gotta remember, I switched up the emitter and the collector. You gotta remember that the emitter always gotta go to ground. Otherwise you could burn up your circuits like that. There we go. Now that I got it flipped around, hopefully we should get some action here. It's filming, right? Alright, good. Alright. So far so good. Let me just... I think we're good. Maybe. Let's turn on the Geiger counter. Maybe we'll get some clicks. If I didn't fry everything. Okay, I'm 90% sure I fried this timer, so let's replace it. It got really hot. It's time for a new one. Good thing these things are like 10 cents each. I fried one of these in my Tesla coil just for fun. Savage. Alright, so I got a new insight onto maybe why this isn't working. So I just tried it again, and I fried this transistor. So that's 32N3904 down for the day. I'm going to try a bigger transistor. Hopefully this TIP120 should do the job. It's a Darlington transistor, which means there are 2 transistors inside it. Alright, let's watch the current when I hook this up. Current is the most important way of measuring success. Okay, we got 0.8 amps on there. That's from the 555 timer's quiescent current. If I touch this resistor to positive, it shorts it out. What the heck? What is wrong? Is this diode messing with something? This is my problem the whole time. This diode is shorted. Alright, well at least I figured out my problem. So, I had a shorted diode, and the shorted diode kept blowing all my transistors. Even when I put the Darlington inside there, I was able to handle the power of the shorted diode. Once I figured out the shorted diode was the issue, I was able to fix that up. Now I've got a working machine, hopefully. Let's charge up that capacitor bank a little more. Oh yes, check that out. It works most of the time. Listen to that. Well, that is pretty cool, I got to say. It works pretty good. I mean, it's not exactly accurate because it's a mechanical counter, but what I did is I put 2 capacitors, so I have a total of 20 microfarads, which gives it a longer on time, and it seems to be working pretty well. As long as you don't have too many clicks per second, then it's fairly accurate, and it goes on average every click. But once you put the americium pretty close to it, and it gives a lot more clicks per second, then it starts messing up and not getting every time. Alright, so awesome news, I got this working. So, funny story, I figured out the issue why this counter wasn't working. Remember before, it wasn't going on every click and it was kind of being a little bit wonky? Well, I figured out the reason why, and that's because I had the negative wire coming from the Geiger counter going into the pulse in on the 5x5 timer circuit, and I had the pulse out of the Geiger counter circuit going nowhere. So why it even worked is beyond me. But anyway, now that I have all the wiring correct, it turns the number on every pulse, which means it works perfectly. Here you go. As you can hear, it's just doing a few clicks. Every time it clicks, it advances a number. Now let's pull out the americium, and I'll show you what happens there. Oh, as soon as I opened that can of americium, it just started going. Here we go. How about 2 things of americium? That thing is going crazy. Remove the americium, it stops. Alright, I say it would be interesting to find out if the counts per minute of my background radiation is relatively the same using this little counter. Let's hook it up. As soon as I hear 1 click of a radiation, I'll start the timer. There we go. If this gets to 22 in the next minute, we'll know the radiation level is approximately the same in the background. So far, that's the exact ratio. That would be 22 per minute. Wow, that's crazy. I got the exact same reading in counts per minute with this little tiny display as I got using my fancier display over here, measuring the counts per minute of background radiation. So that just means that the background radiation stays relatively constant, and a score of 22 means approximately 0.14 millirems per hour. So 0.14 millirems per hour, that's a little over twice the average background radiation of the US, which is pretty cool. I say we try that again with the americium right next to it. Last time I got a very high score with the americium right next to it of about 554. Right now it's at 22, so we should probably get approximately 570. Well, that's 51 seconds, and we've hit approximately 280. Now, that's not the 554 counts that I got last time, but I'm assuming that this number is due to the fact that it's skipping a few counts due to the mechanical nature of the system, and it's not able to catch up when there's a bunch of clicks right next to each other, like the digital system was. But still, this is pretty cool. Let's watch how long it takes until it gets to 570 counts. Alright, it took 2 minutes. So, I guess maybe the amount of radiation coming from that americium sample is half as much? Interesting. Well, that was pretty fun. I had a lot of fun making this pretty cool Geiger counter device. As always, thank you for watching, and stay tuned for next time.